Question 1. What is the defining characteristic of the ML lifecycle within an MLOps context that distinguishes it from a traditional software development lifecycle, SDLC? Option A. Its primary focus is solely on code development and deployment. Option B. It follows a strictly linear progression from data to deployment without revisiting stages. Option C. It incorporates a continuous, iterative feedback loop from monitoring back to retrain. Option D. It prioritizes manual intervention over automation in all stages. The correct answer is, it incorporates a continuous, iterative feedback loop from monitoring back to retraining. Here's the explanation. The ML lifecycle is a continuous, iterative loop driven by MLOps principles, where insights from monitoring deployed models feed back into earlier stages, triggering retraining or model updates, unlike the often more linear traditional SDLC. Question 2. During which stage of the ML lifecycle are phenomena like data drift and concept drift primarily identified and addressed? Option A. Data ingestion and preparation. Option B. Model development and experimentation. Option C. Model monitoring. Option D. Model packaging and registry. The correct answer is model monitoring. Here's the explanation. Model monitoring is the stage where the performance of deployed models is continuously observed for issues like data drift, changes in input data distribution, and concept drift, changes in the relationship between inputs and outputs, which can lead to model accuracy decay. Question 3. After a machine learning model has been successfully trained and rigorously evaluated, what is the next logical step in the ML lifecycle before it can be made available for inference in a production environment? Option A. Model monitoring. Option B. Data ingestion. Option C. Model retraining and updates. Option D. Model packaging and registry. The correct answer is model packaging and registry. Here's the explanation. Once a model is deemed satisfactory, it needs to be packaged, e.g. containerized, with its dependencies, and stored in a central model registry for versioning and lifecycle management before deployment. Question 4. Which statement most accurately describes the relationship between DevOps and MLOps? Option A. MLOps is a completely separate methodology from DevOps, with no shared principles. Option B. DevOps focuses on automating the lifecycle of traditional software, while MLOps extends these principles to specifically manage the unique complexities of machine learning systems, including data and models. Option C. DevOps is only concerned with infrastructure, whereas MLOps only deals with model training. Option D. MLOps is an older methodology that DevOps replaced. The correct answer is DevOps focuses on automating the lifecycle of traditional software, while MLOps extends these principles to specifically manage the unique complexities of machine learning systems, including data and models. Here's the explanation. MLOps builds upon DevOps principles, but extends them to address the specific challenges of machine learning, such as managing data, models, experiments, and continuous monitoring/retraining, in addition to code and infrastructure. Question 5. Which of the following is a core component, unique times to MLOps, distinguishing it from traditional DevOps practices? Option A. Continuous integration, CI, for code. Option B. Infrastructure as code, IAC. Option C. Automated unit and integration testing. Option D. Model monitoring for data drift and concept drift. The correct answer is model monitoring for data drift and concept drift. Here's the explanation. While CI, IAC, and automated testing are core to both DevOps and MLOps, the continuous monitoring of deployed models for data drift and concept drift is a specific and crucial component unique to the MLOps lifecycle, addressing the dynamic nature of MLL models. Question 6. In addition to continuous integration, CI, and continuous delivery, CD, from DevOps, MLOps introduces which two primary, continuous, aspects to manage the ML model lifecycle effectively? Option A. Continuous documentation, CDOC, and continuous security, CSEC. Option B. Continuous testing, CT, and continuous deployment, CD. Option C. Continuous training, CT, and continuous monitoring, CM. Option D. Continuous development, CDev, and continuous innovation, SIN. The correct answer is continuous training, CT, and continuous monitoring, CM. Here's the explanation. MLOps extends CI/CD with continuous training, CT, which automates model retraining, and continuous monitoring, CM, which tracks model performance and data characteristics in production, forming a crucial feedback loop. Question 7. Which of the following best describes the primary responsibility of an MLOps engineer in the machine learning lifecycle? Option A. Exploring data, developing predictive models, and extracting insights to solve business problems. Option B. Building and maintaining robust infrastructure and pipelines to collect, store, and transform high-quality data. Option C. Industrializing the machine learning workflow, automating deployment, monitoring, and CI/CD of ML models. Option D. Defining business problems into ML tasks and evaluating model performance metrics like accuracy and precision. The correct answer is industrializing the machine learning workflow, automating deployment, monitoring, and CI/CD of ML models. Here's the explanation. MLOps engineers bridge the gap between model development and production operations. Their core responsibility is to industrialize the machine learning workflow, automating the deployment, monitoring, and continuous integration/continuous delivery (CI/CD) of machine learning models to ensure they are reliable, scalable, and maintainable in production. Question 8. A team is struggling with ensuring that the exact same features and data preprocessing steps are applied consistently during model training and real-time inference, leading to performance degradation. Which role is primarily responsible for implementing solutions like feature stores and CI/CD pipelines for model serving to address this issue? Option A. Data scientist. Option B. Data engineer. Option C. MLOps engineer. Option D. Business analyst. The correct answer is MLOps engineer. Here's the explanation. MLOps engineers are responsible for industrializing the ML workflow, which includes ensuring consistency between training and serving. This involves implementing CI/CD pipelines, model serving infrastructure, and often integrating with feature stores to manage and serve transformed features consistently for both training and inference, thereby preventing training serving skew. Question 9. In a personalized recommendation system project, who is primarily responsible for developing collaborative filtering or deep learning models and experimenting with different algorithms to maximize recommendation relevance? Option A. Data engineer. Option B. MLOps engineer. Option C. Data scientist. Option D. Software developer. The correct answer is data scientist. Here's the explanation. Data scientists are primarily concerned with exploring data, developing predictive models, and extracting insights. This includes developing and experimenting with different algorithms, like collaborative filtering or deep learning models, to solve specific business problems, such as recommendation relevance. Question 10. What is the core difference in the primary focus between an ML engineer and an MLOps engineer in the machine learning lifecycle? Option A. ML engineers focus on data visualization, while MLOps engineers focus on data cleaning. Option B. ML engineers primarily develop and evaluate ML models, while MLOps engineers focus on operationalizing, deploying, and monitoring these models in production. Option C. ML engineers manage cloud infrastructure, while MLOps engineers write core machine learning algorithms. Option D. ML engineers are responsible for business metrics, while MLOps engineers handle feature engineering. The correct answer is ML engineers primarily develop and evaluate ML models, while MLOps engineers focus on operationalizing, deploying, and monitoring these models in production. Here's the explanation. ML engineers are model builders and optimizers, focusing on the development and evaluation of ML models. MLOps engineers are the operational specialists, ensuring models are reliably and efficiently deployed, monitored, and maintained in live production environments. Question 11. A team member is primarily responsible for selecting appropriate algorithms, performing hyperparameter tuning, and rigorously evaluating model performance using metrics like AUC and F1 score. Which role best describes this individual? Option A. Data scientist. Option B. MLOps engineer. Option C. DevOps engineer. Option D. ML engineer. The correct answer is ML engineer. Here's the explanation. These responsibilities, algorithm selection, hyperparameter tuning, model evaluation, are core tasks of an ML engineer who focuses on developing and optimizing the machine learning model itself. Question 12. An organization needs to automate the deployment of validated ML models to production, set up continuous monitoring for model drift and data drift, and ensure the scalability and reliability of inference endpoints. Which role is primarily responsible for these tasks? Option A. Data scientist. Option B. ML engineer. Option C. MLOps engineer. Option D. Business analyst. The correct answer is MLOps engineer. Here's the explanation. Automating deployment, setting up continuous monitoring for drift, and ensuring scalability/reliability of production endpoints are key responsibilities of an MLOps engineer who focuses on the operational aspects of the ML lifecycle. Question 13. What is a key differentiator of continuous integration, CI, for ML, compared to traditional software CI? Option A. It focuses solely on compiling code and running unit tests. Option B. It extends to include automated testing of data quality, model performance, and the underlying ML infrastructure. Option C. It primarily involves manual code reviews and approvals before merging. Option D. It eliminates the need for version control systems. The correct answer is: it extends to include automated testing of data quality, model performance, and the underlying ML infrastructure. Here's the explanation. While traditional CI focuses on code build and unit tests, CI for ML expands its scope to include ML-specific concerns like data validation, model performance evaluation against baselines, fairness testing, and validation of infrastructure as code for ML resources. Options A, C, and D are incorrect characterizations of CI for ML. Question 14. In a continuous integration pipeline for ML, what is the purpose of data validation as an automated step? Option A. To encrypt sensitive data before it is used for training. Option B. To ensure the new incoming data is consistent with expected schemas, data types, and value ranges, and to detect potential data drift. Option C. To compress the dataset for more efficient storage. Option D. To manually label new data points for model retraining. The correct answer is: to ensure the new incoming data is consistent with expected schemas, data types, and value ranges, and to detect potential data drift. Here's the explanation. Data validation in CI for ML is a crucial automated step that checks the quality, consistency, and statistical properties of input data. It verifies schema adherence, checks for missing or out-of-range values, and can identify data drift, ensuring that the data used for training or evaluation is reliable and conforms to expectations. The other options describe different data-related tasks, not directly part of automated data validation in CI. Question 15. When an MLOps engineer commits a change to a Terraform configuration file defining ML infrastructure, what role does the CI pipeline play? Option A. It automatically applies the Terraform changes to the production environment without review. Option B. It performs static analysis on the Terraform code, validates its syntax, and executes a Terraform plan to preview changes. Option C. It triggers a full model retraining process immediately. Option D. It only checks for Python code errors within the Terraform file. The correct answer is: it performs static analysis on the Terraform code, validates its syntax, and executes a Terraform plan to preview changes. Here's the explanation. For infrastructure as code, IAC, changes, the CI pipeline validates the configuration. This includes static analysis, syntax checks, Terraform validate, and generating a plan, Terraform plan, to preview the infrastructure changes, ensuring correctness and adherence to policies before actual deployment. Option A describes an unsafe practice, and C and D are incorrect roles for IAC validation. Question 16. What is the primary goal of continuous delivery, CD, for machine learning? Option A. To ensure that every model update is automatically deployed to production without any human intervention. Option B. To automate the initial training and evaluation of ML models in a development environment. Option C. To guarantee that ML models, along with their associated code, data, and infrastructure, are always in a deployable state and can be released reliably and rapidly. Option D. To manually review and approve every model change before it enters the CI pipeline. The correct answer is: to guarantee that ML models, along with their associated code, data, and infrastructure, are always in a deployable state and can be released reliably and rapidly. Here's the explanation. Continuous delivery for ML aims to keep models and their components in a constant state of readiness for deployment, enabling rapid and reliable releases. Option A describes continuous deployment, which is a further step beyond CD. Option B is part of continuous integration. Option D contradicts the automation principles of CD. Question 17. Which deployment strategy involves routing a small percentage of live traffic to a new ML model version, gradually increasing it if no issues are detected? Option A. Blue/green deployment. Option B. Canary deployment. Option C. A/B testing. Option D. Rolling update. The correct answer is canary deployment. Here's the explanation. Canary deployment is a strategy where a new version of a model is released to a small subset of users or traffic. If it performs well, the traffic is gradually increased until it replaces the old version entirely, minimizing risk. Blue/green involves spinning up a completely new environment and switching traffic. A/B testing compares different versions to different user segments. Rolling update gradually replaces instances of the old version with the new version. Question 18. During the automated staging tests in a CD for ML pipeline, which type of validation is uniquely critical for machine learning models? Option A. Unit tests for the application's user interface. Option B. Infrastructure as code, IAC, syntax validation. Option C. Data validation, model performance validation, and fairness testing. Option D. Security penetration testing of the API gateway. The correct answer is, quote, data validation, model performance validation, and fairness testing. Here's the explanation. While all options represent important tests, data validation, e.g., schema, range, distribution, model performance validation, e.g., accuracy, precision, recall against baselines, and fairness testing, are uniquely critical automated tests for ML models during the CD staging phase. These directly address the specific challenges of ML model degradation due to data or model changes. Options A, B, and D are more general software or infrastructure testing concerns. Question 19. What is the primary driver for implementing continuous training, CT, in MLOps? Option A. To reduce the initial computational cost of model development. Option B. To ensure that deployed models remain accurate, relevant, and performant over time by adapting to changes in data distributions or concept drift. Option C. To manually fine-tune model hyperparameters on a daily basis. Option D. To replace human data scientists with fully automated model development systems. The correct answer is to ensure that deployed models remain accurate, relevant, and performant over time by adapting to changes in data distributions or concept drift. Here's the explanation. Continuous training is implemented to combat model degradation due to data drift, concept drift, or evolving real-world patterns. It ensures models stay relevant and accurate post-deployment. Options A and C are incorrect, and D is an overstatement of CT's goal. Question 20. Which of the following components is crucial for ensuring reproducibility and tracking the evolution of models within a continuous training pipeline? Option A. Manual code review processes. Option B. Automated UI testing tools. Option C. Data versioning, model versioning, and experiment tracking. Option D. Static IP addresses for all training infrastructure. The correct answer is data versioning, model versioning, and experiment tracking. Here's the explanation. Data versioning ensures the exact dataset used for training can be retrieved. Model versioning tracks different iterations of trained models, and experiment tracking logs all parameters, metrics, and artifacts for each run. Together, these enable reproducibility, debugging, and understanding model evolution, which are vital for CORT. The other options are either unrelated or less critical for reproducibility in CORT. Question 21. A continuous training, CT, pipeline is most likely to be triggered by which of the following events? Option A. A new developer joining the ML team. Option B. A scheduled time interval, e.g. weekly, detected performance degradation, or significant data drift. Option C. A change in the company's marketing strategy. Option D. A manual request to deploy an untested model directly to production. The correct answer is a scheduled time interval, e.g. weekly, detected performance degradation, or significant data drift. Here's the explanation. CT pipelines are typically initiated by automated triggers. These can be time-based, scheduled retraining, event-based, new data accumulation, or performance-based, model accuracy drop, data or concept drift detected by monitoring. The other options are either irrelevant or describe actions that would bypass or contradict CT principles. Question 22. What is the primary reason ML models require continuous monitoring for data drift or concept drift, which is less common for traditional software applications? Option A. ML models are typically deployed on less stable infrastructure than traditional software. Option B. Traditional software applications are immune to changes in input data distributions. Option C. ML model performance can degrade significantly over time due to changes in the underlying data patterns or the relationship between inputs and outputs in the real world. Option D. Continuous monitoring for drift is a regulatory requirement for all software, not just ML. The correct answer is ML model performance can degrade significantly over time due to changes in the underlying data patterns or the relationship between inputs and outputs in the real world. Here's the explanation. ML models learn patterns from data, and their effectiveness is highly dependent on those patterns remaining consistent. Data drift, changes in input features, and concept drift, changes in the relationship between features and target, directly impact model accuracy and relevance, making continuous monitoring for these phenomena crucial. Traditional software's logic is deterministic and less affected by such external data shifts. Options A, B, and D are incorrect or overgeneralizations. Question 23. A sudden, statistically significant change in the distribution of input features between a model's training data and its production inference data is known as what? Option A, model staleness. Option B, concept drift. Option C, data drift. Option D, infrastructure failure. The correct answer is data drift. Here's the explanation. Data drift specifically refers to changes in the distribution of the input features. Concept drift refers to changes in the relationship between the input features and the target variable. Model staleness is a general term for a degraded model, which can be caused by drift. Infrastructure failure is a separate issue related to the underlying hardware/software. Question 24. After a continuous monitoring system detects a significant drop in an ML model's accuracy, what is the typical next step in the feedback loop? Option A, immediately roll back to the previous model version without further analysis. Option B, automatically redeploy the same model, assuming a transient error. Option C, trigger an alert, prompting ML engineers or data scientists to investigate the root cause, and then take corrective action like retraining or data re-engineering. Option D, permanently retire the model and develop a new one from scratch. The correct answer is trigger an alert, prompting ML engineers or data scientists to investigate the root cause, and then take corrective action like retraining or data re-engineering. Here's the explanation. The feedback loop in continuous monitoring involves detecting an issue, alerting the relevant teams, investigating the root cause, which could be data drift, concept drift, or other problems, and then taking appropriate corrective actions. Options A, B, and D represent premature or drastic actions without proper investigation, which is a key part of the monitoring feedback loop. Question 25. Which of the following best defines ML technical debt? Option A, the cost associated with purchasing cloud computing resources for ML training. Option B, the accumulated cost of future rework resulting from short-term solutions in ML system development. Option C, the financial investment required to hire expert data scientists and ML engineers. Option D, the overhead introduced by implementing automated CI/CD pipelines for ML. The correct answer is, quote, the accumulated cost of future rework resulting from short-term solutions in ML system development. Here's the explanation. ML technical debt refers to the accumulated cost of future rework that arises from choosing easy, short-term solutions during the development and deployment of machine learning systems, rather than investing in more robust practices. Question 26. A data science team rapidly develops a fraud detection model using a manually cleaned dataset and ad hoc scripts for feature extraction, without versioning or robust data pipelines. This approach is most likely to contribute to which type of ML technical debt? Option A, model debt. Option B, monitoring debt. Option C, data debt. Option D, infrastructure debt. The correct answer is data debt. Here's the explanation. Data debt includes issues like untracked data dependencies, inconsistent data quality, lack of data versioning, and failure to adapt to data drift, which are all consequences of manual and ad hoc data handling. Question 27. Which MLOps practice directly helps mitigate ML technical debt related to model staleness and the inability to adapt to data drift or concept drift? Option A, relying on manual model deployments for critical updates. Option B, implementing automated retraining pipelines triggered by monitoring insights. Option C, storing all ML code in monolithic Jupyter notebooks. Option D, minimizing experiment tracking to reduce overhead. The correct answer is implementing automated retraining pipelines triggered by monitoring insights. Here's the explanation. Automated retraining pipelines, often triggered by monitoring systems detecting data drift, concept drift, or performance degradation, directly combat model staleness by ensuring models are updated with fresh data and remain relevant. Thanks for watching. Please subscribe to my channel.